Hey guys, welcome to the video on mechanical energy and the conservation of energy. I have two goals for this lesson. I want you to explain the conservation of energy, and I want you to solve problems that involve the conservation of energy. So, I guess the question is, what is the conservation of energy? Well, it is the total amount of energy in joules always stays the same. It just changes form. So, like, if you have potential energy, that potential energy can turn into kinetic energy, and the kinetic energy can turn into potential energy. But these two are always going to remain the same, so you can't just make energy appear. So, an example, if you have 100 joules of potential energy and the object falls, it turns into 100 joules of kinetic energy. And that's basically it. That's all the conservation of energy is saying, is that the total amount of energy stays the same. In this case here, at the end, after it falls, the potential energy would be 0, and the kinetic is now 100. So the potential turned into kinetic. Now this plays into an idea called mechanical energy. Mechanical energy is the sum of all kinetic and potential energy in a system. Now a system is just kind of like a situation. It's something that you look at. Like right here, this would be a system. It's a guy who is smacking a nail on a board. The formula for mechanical energy is going to be kinetic energy plus potential energy. But here it says the sum of potential energy. Now, when it says the sum, what it's referring to is you have to add together your elastic and your gravitational, because these are both types of potential energy. So when you see this fancy thing here, which says the sum of potential energy, all it's really saying is that you have to add together elastic and gravitational. So if you add together kinetic and potential, you get something we call mechanical energy. So kind of like explaining like from a 5-year-old, what this basically means is that it is the movement and potential energy just added together. And that's all that mechanical energy is. Now, why is this important? Well, what this means is this. It means that mechanical energy is always the same. Because remember, things can change back and forth between potential energy and kinetic energy, but they cannot stop. They'll always be equal in the system. So, this is where the problems start getting hard, guys. I told you beforehand that the problems from here have been pretty simple so far. Well, now they're about to get not simple. Sorry about that, and I wish I was there to help you guys through this stuff, and I will be back on Wednesday to help you, but this is going to be a little bit tricky, guys. There's no way around it. The conservation of mechanical energy is this formula right here, in which you see that mechanical energy initial is equal to mechanical energy final. So what that means is your initial energy is the same as your final energy. Now, let's hit this with a problem, because I think a problem would be best to help explain what this actually means. And this problem is going to be pretty hard, guys, so feel free to watch this part a couple of times if you don't understand it. So let's say we have a bird flying with the speed of 18 meters per second over water when it accidentally drops a fish that is 2 kilograms. If the altitude of the bird is 5.40 meters and friction is ignored or disregarded, so we don't care about friction, what is the speed of the fish when it hits the water? Maybe thinking to yourself, I have no idea. Well, we can use the formula back here because we know that the energy at the beginning is the same as the energy at the end. So my first tip for you guys here, and if you don't do this, you're going to have a really bad experience. Write down everything you know. So what I do is the very first thing I do is I write down, I know the initial velocity, I know the mass, I know the height. I don't know final velocity, and it's what it wants me to solve. So what can I do here? Well, the first thing I can do is I can find out the potential energy at the very beginning. And the beginning potential energy is just 2, which is going to be the mass, times gravity, times the height. So my potential energy is going to be 106 joules. And I can get that from the problem. But I also have kinetic energy as well, because I have velocity, the bird is flying. So I take 2, which is the mass of the fish, multiplied by 18, which is the current velocity of the bird, the fish, and that gives me 324 joules. Now, because mechanical energy is potential energy plus kinetic energy, that means my mechanical energy is 430. And since we know mechanical energy is equal to the mechanical energy at the beginning is equal to the mechanical energy at the end, we know that mechanical energy at the end, or final, is equal to 430. And we know that since the fish is currently at the bottom, there's no more potential energy. So we know that 430 here is now all kinetic energy. So all we have to do now is plug it into the kinetic energy formula. So 430 is equal to the mass times the velocity squared divided by 2. And if you run that problem through, you get the velocity as 20.7 meters. So that's how fast the fish is going when the fish hits the water. As you can see, guys, these problems are a lot more challenging than the ones we've been doing earlier. They require a lot of steps. And you're really, guys, it's really important here to stay as organized as possible, which is why I write everything down step by step. Otherwise, it's very easy to get lost here. So what I want you guys to do today, I want you to go on to Edmodo and download the mechanical energy worksheet and diagram on Edmodo. I want you to complete this with your partner, and part of this activity is a poster. And the instructions for this poster are going to be in a worksheet. The first part of the activity is practice problems. The second part is a poster you're going to create. If you finish ahead of time and you're done with the activity and with the poster, go ahead and work on your homework, which I have also put on Edmodo. All right, guys, thank you very much, and I will see you all on